One of the highest priorities is to understand how polar oceans are changing. We're trying to unravel how small changes in the physical ocean ripples all the way through to the highest trophic levels like penguins and whales.
Sea ice was the key. And the reason it was a key is if you look at biology, it often follows the edge of the sea ice. So over winter time, you grow a huge amount of sea ice, and then it melts back in summer. Along that sea ice edge, you'll find whales, you'll find seals, you'll find penguins, and the question is why? Well, if you think about the plants that form the base of the food web, they're dependent on light to essentially drive photosynthesis. So if you blow very hard and you deeply mix the water, you increase the time the plants are in darkness and they don't have enough light to grow. So here in this ocean where it's very windy, where do you find the blooms? Well, you find it where the ocean's protected from the wind. And one place that occurs is in the marginal ice zone. It's the physicists I don't trust.
Marine ecosystems begin, like other ecosystems do, with photosynthesis by plants.
Plants in the ocean are very small. Average size might be anywhere from 50 to 100 microns. So these are the forests of the sea. They produce about half the oxygen on Earth, and so they're very important for regulating the Earth system.
Phytoplankton are consumed by zooplankton. The principal zooplankton in this system is the Antarctic krill. The krill are important because they're the key link between the photosynthesizing phytoplankton, the primary producers, and all those upper level predators.
Zooplankton are small drifting animals in the ocean. The word zooplankton actually means animal drifter in Greek or Latin. And so we study the zooplankton, and the most abundant ones are the krill, and those are a very important part of the food web here in the Southern Ocean. Lots of things eat krill. The whales, the seals, the penguins are all dependent upon krill for food.
So krill are amazing because they're such a life force in this part of Antarctica, especially the Antarctic krill. They're very small, and very rarely do you get this short food chain in other parts of the world. I feel like this system is unique because this Antarctic krill, this tiny animal, is supporting whales by, supporting animals that are so much larger than themselves.
Here, go back. Oh, I got that one. That was the right one.
This whole place on Earth is melting. And as it melts, now all the biology is responding. And because we started 20 years ago, we've been following that change. Science is a very difficult problem, and if you think of it, it's like you're trying to describe a system you don't understand, and now you combine that with climate change, which is something that happens over 50 to 100 to 1,000 years. And even though we've been doing it 20 years, we don't have nearly enough data. We have just as many questions now as we did when we began.